Good evening. Am I audible? මාව ඇහෙනව නේද?
Yes, sir.
All right. Any questions from last day session? මොන හරි ප්‍රශ්න තියෙනවද? කලින් last day එකේ අරපු කරපු session එකේ මම අර activities වගේ එකක් දුන්නා. මේ ගැටලු තියෙනවද මොන හරි? Any questions from last day session? I think no. Then other session එකට යමු. මොන හරි තියෙනවා නම් අන්තිමට හරි කියන්න. Right? Yeah. Mohammed, any questions? Right, we'll start. Right. මාව හොඳට ඇහෙනවද දන්නේ අද මේ මේ ගෙවල් ළඟ තියෙන ග්‍රවුන්ඩ් එකක ඒකේ මේ මියුසිකල් ෂෝ එකක් හරි මොකක් හරි එකක් තියෙනවා right ඒක හින්දා ඔයාලට මොකක් හරි බාධාවක් තියෙනවද මගේ වචන ඇහෙනවද can you hear me properly
Yes, sir.
Alright. Yes. Okay. Right, today we are discussing fact analysis actually. It means how to check the validity and reliability of a questionnaire. So these are the learning outcomes of today's lecture. At the end of this lesson, you will be able to understand the purpose and applications of fact analysis, differentiate between principal component analysis and common fact analysis, perform principal component analysis in SPSS and interpret key outputs, apply principal axis factoring and maximum likelihood use Verimax notation and direct opt-in rotation methods, generate interpret factor scores for further analysis, apply factor analysis techniques to simplify data and identity key patterns. Right, Muhammad, I think you tried to ask a question. I didn't hear it properly. Isn't it? Muhammad, anything to ask? Right, if you have a question, so you can ask, okay? Introduction. So, if we consider a questionnaire, right? So sometimes there are some factors. For an example, the psychological factors. So we can't measure directly. සමහර factors තියෙනවා අපිට කෙලින්ම measure කරන්න බෑ. For an example, මෙන්න මෙහෙම හිතන්නකෝ. So marks of the students for a specific subject. So definitely we can take directly. Doesn't matter. Marks for science. marks for mathematics, marks for any other subject. So we can find directly. So then if you need to find motivation to learn mathematics, so can we ask from the students, are you motivated to learn mathematics? So they can tell yes or no, but it is not the exact answer, right? For those kind of, so if we need to measure their motivation, so we have to use then some validated question or an instrument check uh, to check their motivation. So likewise that the variables we cannot be observed directly. So we call those are latent variables. අපිට directly measure කරන්න බැරි ඒවට අපි කියනවා latent variable. ඒතකොට ඒවා measure කරන්න නම් අපිට බලන්න වෙනවා. We have to ask some series of questions. ප්‍රශ්න ගොඩාක් අහන්න වෙනවා. So but by taking these questions together, so we can say something about that latent variable. So in here also I given you one example, one latent variable, that is SPSS anxiety. So, but the anxiety is actually a psychological factor, no? Therefore, that is also we can't measure directly. So we can't ask, have you have that have you suffering with anxiety? ඒ වගේ question ඇහුව කියලා ඉතින් වැඩක් නෑ. Therefore, what we need to do means we know so we have to ask indirect questions from the group of participants to say to check whether they have the SPSS anxiety or not. So the in here what I want to call in here what I want to tell is that in here what I want to mention that to uh, find these latent variables, so we have to take some observed variables. Right, so we need to take some observed variables. එතකොට අපි සමහර questions කීපයක් අපිට අහන්න වෙනවා. So we call those are observed variables, right? So then here, so that assumption is the correlations among all observed variables can be explained by the latent variable. So it means, so this recall, if we take the correlations with these items, it means these questions and the SPSS anxiety. So that should be highly correlated, right? So that's again මේ දෙන්නගේ අපි correlations බැලුවොත් ඒක highly correlated වෙන්න ඕනේ. It means that we can use these unobserved variables to say something about these unobserved variables. It means these latent variables. I think you got the idea about what is latent variable and the observed variable. Latent variable කියන්නේ ඒක අපිට measure අපිට ගන්න බෑ. For an example මේ anxiety කියන්නේ psychological contents ගොඩක් ඒවා එන්නේ මේ latent variable anxiety. So we can't measure directly. There's motivation to learn a subject. So we can't measure directly. And also we call them some other psychological concepts called metacognition. So we can't measure directly. So for that we have to use the group of unobserved variables, right? So so I will take a questionnaire, right? Somebody questionnaire එකක් ගත්තා. SPSS anxiety questionnaire, right? Like this. So suppose yeah, so you can see here attitudes towards statistics and technology. So instructions. So this questionnaire assesses participants' attitudes towards uh, statistics and technology used in data analysis. Please indicate the extent to which you agree or disagree with the following statement by selecting a number from 1 to 5. So it is defined here where 1 is strongly disagree, then 5 is strongly agree. Yeah, so then these are the 8 questions. ඒක තමයි questions are. These questions are there, right? So then here you have to mark. So you have to underline or you have to circle here. What you need to be, yeah. Right? Suppose then these are the observed variables. මේ තමයි මේ questions අට තමයි observed variables. Like here, these 8 items are observed variables, and by taking as all of these items as one, so we can create a latent variable called SPSS anxiety. So we'll see what are the questions there. පිනිකම් බලමු මොන මොන වගේ questions ද තියෙන්නේ කියලා. Statistics may cry, right? My friends will think I am stupid for not being able to cope with SPSS. Standard deviation excites me. I dream that the Pearson is attacking me with correlation coefficients. I have little experience with computers. I don't understand statistics. All computers hate me. I have never been good at mathematics. Likewise, these are some questions that participants need to be checked. Strongly disagree or strongly agree or whatever the number between 1 and 5. Right then, after, yeah, then what we can do is we can collect these questionnaires and we can enter those data into SPSS worksheet, right? Yeah, then we can check whether there are correlations. Correlations then we can check whether there are correlation between these items, right? We'll see then. We can find the correlation. We can find the correlation. This is actually a practical example, so I will show you. Right, here you can see if you consider variable Q1 to Q8 is there. So here, this is you can see uh, 1 is strongly disagree, 2 is disagree, 3 is neither, 4 is agree, 5th is strongly agree, then 9 is not answered. If not answered, we have 9. Then here you can see මෙතන තියෙනවා ඇත්තටම yeah the records of 2571 people. මිනිස්සු 2571ක details මෙතන තියෙනවා. Right? So then Q1 to Q3, it's you can define here. Q1 කියන්නේ මොකක්ද කියලා මෙතන define කරලා තියෙනවා. Right? Q1 means that first question is statistics makes me cry. Second one is students will think I am stupid, but I stupid for not being able to cope with SPSS. Standard deviations excite me. I dream that Pearson is attacking me with the correlation coefficients. I don't understand statistics. I have experience of computers. All computers had me. Right then, you can see here that next question is I never been good at mathematics. These are the 8 questions. 8 questions අතර තමයි 2000 ගණක් එන්ටර් කරලා තියෙන්නේ. Right? Then we can check the correlations of what everything, right? So then we can go analyze, sorry, yeah, analyze. Right. So then we can see here Pearson's correlations, right? We'll see then. So these are the data set. Data set. Then we can find the correlation. Analyze, correlate, bivariate. Yeah, yeah, this is the output. So here you can see මෙතන බලන්න, so if we consider this psychological concept is that anxiety, right? So we have to find whether these findings are matched with them. Yeah, the values are same. Negative 0.99 here, then see, negative 0.337, 112. Right. So likewise, we can find the correlations actually. Right, partition the variance in factor analysis. Common variance. Variance that is shared among the set of items. Commonality x squared, common variance that ranges between 0 and 1. Unique variance, the variance that is not common. Separate, variance. Uh, uh, Variance that I is specific to uh, spec particular item. Then all four components hate me. Anxiety about computers, addition, anxiety about uh, equal variance. Anything to anything unexplained by common or specific variance. Mother got a call from his baby sister. She is 2 years. So then here then just we are going to talk about principal component analysis now, right? In principal component analysis, H square we are taking as 1, okay? In PCs, there is no unique variance. Common variance across a set of items and makes them total variance. Here, so I told you that, so the unobserved variable is SPSS anxiety, but then this is total variance, common variance, unique variance, then specific and error we need to add here. Extraction plus factor and factor rotation. Fact extraction, that the type of model PCA or EPA. Estimation method, principal access factoring or maximum likelihood. Number of factors or competence to abstract. Then factor extraction we are trying to discuss. Then factor rotation. Archive simple structure orthogonal oblique. Right. So then we will see extracting factors, how we can extract the factors. Principal component analysis with 8 and 2 components. Common factor analysis, principal axis factoring, principal likelihood. Principal component analysis. Further, we can use abbreviated PCA, that means principal component analysis. Right. PC, principal component angle analysis, eigenvalues and eigenvectors. Eigenvalues. Total variance explained by given principal component. Eigenvalues greater than zero is good. Negative eigenvalues encountered. Eigenvalues close to zero, it means there is multidimension. And eigenvectors. What eigenfactors? Then weight for each eigenvalue, eigenfactor times square root of the eigenvalue scores component loadings. Component load is correlations of item with the principal component. Eigenvalues are the sum of the square uh, components. And component loadings. Uh, correlation of each items with principal component. Eigenvalues are the sum of the squared component loadings of all items for each component. So the minimum correlations, component loadings, eigenvectors, total eigenvalues, those things we can discuss when we are taking an output. Right? Then for an example, first we have to run a principal component analysis with 8 components, right? 8 components. So then for that I have make it, this question, this question here, it includes uh, it includes 5,700, sorry, 2,571 inventories, right? 2,571 inventories. So under these 8 questions, my questions are that එයාලා අහපු ප්‍රශ්නෙට දීපු answers තියෙන්නේ මේ, right? 1 to 5 answers හම්බෙලා තියෙන්නේ. Then we can analyze later, right? So then first thing is that we need to check whether these are reliable or not. Reliability බලන්නේ එහෙම analysis, scale, reliability analysis. So we make a fact analysis එකට කියලා බලමු. Analysis, dimension reductions, fact analysis, sorry, මේ අපි reliability එකට කියලා බලමු. Analyze scale වලට කියලා යන්න reliability analysis. So we can select this all. Then just we'll see the answers. Yeah. So scale for all variables. So make a reliability available. Number of items 8. 0.459. 0.45 and 0.5 again. So, but so to have a good um, So අපි දන්නවා question එකකට at least 0.6 7වත් තියෙන්න ඕනේ this cron batch alpha value. So what we can do is here item and total statistics තියෙනවා. අපි statistics ටික දීලා තියෙනවා. Then you can see here scale statisticians, right? එයාලා මෙන්න මේවා දීලා තියෙනවා. ඒකෙත් n variance equals to 8. right. එතකොට මේකේ මේ item if deleted කියන එක ආවිලා තියෙනනේ. So මේකේ ආවිලා තියෙන්නේ 0.5 නේ. දැන් මේකේ හොඳට බලන්න මේ analysis එක scale mean if item deleted. Likewise it's mentioned there. මෙතන එක mention කරලා තියෙනවා, right? So from there you can find with කොතැනද මේක දාන්නේ කියලා එතනින් තමයි බලන්න ඕනේ. So then if we need to improve our reliability, but මට reliability එක improve කරගන්න ඕනේ. මොකද කරන්නේ? Just we can say එතන මෙන්න මේකේ හොඳට බලන් යන්න. Front batch alpha if item deleted. item එක delete කරාට පස්සේ front batch alpha value එක බලන්න මේකේ මෙන්න මේක delete කරාම හරි මේ 0.662ට යනවා. So what we need to delete is standard deviation excites me. ඒක අයින් කරලා බලමු අපි. Right? Then we'll go analysis. ඒක අයින් කරනවා කියන්නේ අපිට analysis එකම අයින් කරන්න වෙනවා. Descriptive statistics. So the standard deviation excite me කියන එක අපි අයින් කරලා බලමුකෝ මොකද වෙන්නේ කියලා. Yeah. So then here you can see reliability increased. Reliability එක. If you need you can දැන් නම් ඕනේ දැන් 0.8ට වඩා වැඩි වෙලා තියෙනවා මේක. Now it's good. Right? Right. Then we'll see අපි දැන් reliability බලුවා reliability testing. Then we are going to talk about principal component analysis. Then we can go then here they selected these items, right? Right. We'll go for a principal component analysis. අපි යම් principal component analysis එකට. So we can go analyze it. We'll see analyze scale reliability analysis, right? Right, we'll go for a example again. Okay. Yeah, we can go for a factor analysis dimension reduction. So we can take analysis. So then we can go here, right? So yeah, Cronbach alpha value we can take here methane avalazine 0.459, that is the Cronbach alpha value. Then we can go for a principal compound analysis. For that, we can go analyze uh, dimension reduction factors. Analyze dimension reductive factors. Under here, you have to select all. Right, you can see here. අපි බලමු මේක කොහොමද interpret කරගන්නේ කියලා. Right? So then we can take uh, you can take this output from sorry the SPSS output the reliability output එක මම පේනවා. දැන් අපි මෙතන පොඩි dimension reduction නැත්නම් factor analysis එකට චුට්ටක් කියන්නේ principal component analysis ඇත්තටම. Right? So then here reliability we found. Then we can go for the principal component analysis. For that, analyze legacy dialogues. Yeah, right. Analyze dimension reduction factor. Yeah. So then we'll go for a principal component analysis. Right. Yeah, we'll see these documents. Then here component matrix. Then අපි යන්නේ මෙතන මේක principal component analysis වලට. Right. So here you can see here statistics may cry. මෙතන statistics may cry කියන එක තියෙනවා 0.659. මෙතන ඇවිල්ලා තියෙන්නේ 136. Right. වෙනසක් තියෙනවා. Component loadings. Correlation of each items will be with the principal component. Sum of square loadings across components. එතකොට මේකේ 0.659 ඇතුළේ තියෙනවා. It is it means it's equals to 0.453. It means 43.4 no the variance explained by the first component rank R square. Right. So you can see here here some values there. Whether it's values to there may eigen values. Then it's equals to 1 always. Eigen values හැම වෙලේම එකට සමානයි. Right එහෙම වෙනස් වෙන අවස්ථාවක් තියෙනවා. Right, we'll take the out analyze dimension reduction, factor analysis. Then this is the output. We'll talk about one by one. This one, so we call this total variance explained. It's given as these values. Pre-report also we can see that they had it in a elbow එකක් විදිහට මේ විදිහට තමයි එන්නේ. Choosing the number of components to extract. Right. So we'll go for an example. Right. So we can follow this step, analyze dimension reduction factor. So we'll go then. Analyze dimension reduction factor. I'm checking the sum one, then we can, okay. Right. එතකොට මේ තමයි principal component analysis එකට අපිට ඇවිල්ලා තියෙන values ටික. Right. So then recall these numbers in from the 8 component solution. මේ numbers ටික අපිට ආවා 8 component solution එකේ. Right. Notice only two eigenvalues. 84 point of the total variance in item 2 explained by 1. Right. We'll go for this is how we can do this actually. Principal factor. මේ ටික තමයි අතරම ගන්න පුළුවන්. Right. So here yes, statistics may cry. So we found its value as 0.530. Right. So then we'll come to extracting factors. Right. Extracting factors. Actually, there is a common factor analysis, principal axis factoring, and maximum likelihood factoring. Yeah, factor analysis. Right. We'll go for factor analysis now. The goal is also reduce the dimensionality. අපිට reduce කරන්න පුළුවන්. It means if you have correlated items, ඊට පුළුවන් එකතු කරගන්න. But assume that variance can be divided into common and unique variance. Make more sense to define, construct, measure error. Let's find the correlations. අපි මේක correlations බලමු. then එතන important analyze correlate by variance. Right, these are the correlations. We'll see the values. 0.99. Yeah, 0.99 is there. Likewise, we can take the outputs. Right, now we'll go for factor analysis. Right, analyze, scale, sorry, මෙන්න මේ flags එක මෙන්න මේ values ටික. දැන් අපි යමු factor analysis එකට. එතකොට analysis, general linear models, univariate. We'll go for factor analysis again. We check. And we'll go analysis, dimension reductions, factor. Yeah, so these are the outputs. මේවා තමයි outputs එන්නේ. Then we'll go print for the principal component analysis. Again, we'll check analysis. Dimension reduction factor. Then we can go for the extraction. Right, this is we have to check principal axis factoring here now. It's we can go to principal axis factoring, right? So then here we can apply for scree plot as well. Then number of factors equals to 2 here. Then number of iterations, it's mentioned as 100. We'll see the outputs. Yeah, same outputs you can see 293, 106, 298. Yeah. Then here you can see the descriptive statistics in fact analysis. Mean standard deviation is there. Then here it's commonalities is there. And total variance explained is also there. So then here you can see and scree plot. So I showed you this elbow. Then it is also available here. Right. Then initial commonalities are the shared multiple correlation coefficient controlling for all other items in your model. What was internal community factor analysis? Make a principal component analysis again. Unlike principal component analysis, some of the initial eigenvalues do not the sum of squared loadings, right? So then here you can say sum of the eigenvalues. All sum is equals to negative 4.124. The Pearson is because eigenvalues are principal component analysis, not for factor analysis. SPSS I do. Then so we'll discuss how we can. Right. Right. So then here that we are separating into groups but without considering these eigenvalues. Eigenvalue copy then eigenvalues greater than 1. So we can take for online. So then uh, eigenvalues are only for principal component analysis, yet SPSS uses eigenvalues criteria for EFA. When you look at the scree plot, you can see here making process decision to use principal component analysis solutions as approximately for exploratory fact analysis වලට ඔය equal කියලා කියනවා. Right? We'll see then. Analysis will go analysis, dimension reduction, fact. Right? Fact analysis. Yes, we can take this whole. Right? Then speciality in here is so we have to check eigenvalues greater than one. Yeah. Next one, fact analysis, two-factor principal axis factoring. So this is factor matrix, and these are the other findings. So these are analogs to the component loadings in principal component analysis. So here you can see that starting the loadings and the summing up gives either the community or the extraction sums loadings squares. Right. The second one is right. We'll see another one. Right. So in here also the same thing, right? So earlier that person's use a book. That same thing can be happen. Right. Right. Factor matrix. A two-factor matrix එකක්. These are analogs component in principal component analysis. Analog විදිහට මේ අරගත්ත ඒවා. Squaring and loadings, the summing of give you either give community or extraction sum of these paired loadings. Summing down the formalities so across the eigenvalues give the total variance explained by 3.01. Right, so in here if we consider that, so we can hear that the total remaining value is this one. Right, sum of the squared loadings across the factors of unidimensionality is called uh, communities. Right, then here also you have to remember that. So yeah, so the sum of the squared loadings of each column, extraction of sum of the square rootings, not eigenvalues. Then this is a part diagram. So once you found these values, so you can use this part diagram. මේ values ටික හොයාගත්තට පස්සේ අපිට part diagram එකක් පාවිච්චි කරන්න පුළුවන්. So why we are using these kind of questionnaires so you know uh, right. So ඒවා directly observe කරන්න බැරි ඒවට අපිට මෙන්න මේ වගේ system එකකට යන්න වෙනවා. Right? Yeah. So the relationship between three tables. Yeah. Eigenvalues, principal component, sum of the squared loadings. Right. Factor component matrix. So then square of each element, then you have to take the square loadings and go to the other side. Sum across the factors or the components. Right. Then next go to the maximum likelihood estimation, two-factor model. Right. So the process is same. Analyze, the analysis dimension reduction factor. Analysis. Right. Then chi-square comparison table is there. So the chi-square degrees of freedom is pros. There are factors model is preferring from chi-square. So so we can use chi-square test actually. This is actually eight-factor model. So sometimes you have to remove some models. They are not giving permissions to get to that country. Anyhow, that so if we consider these effect site measures, right? Right. So then comparing EFA and PCA, මේක කොහොමද compare කරන්න කියලා බලමු. EFA's total variance explained. Uh, for the both models, communities is the most proportion of variance due to all teachers for components in the model. Yeah. So you can observe these tables. You can see here total variance explained in here. Total variances are there, right? Rotation methods, right? Rotation methods අපි බලමු. Simple structure. The simple structure method එකක් යනවා. Right? Then orthogonal rotation very much මෙන්න මේ පැත්තත් යනවා. Right? So the simple structure rotation එක මෙන්න මේ විදිහට යන එකක් අපිට ගන්න පුළුවන්. Right? So we'll go again. Right? Let's see then. We'll take. We'll see. Sometimes this is available. No. Yeah. So right. Running two-factor solution. Right. Without rotation, first is the most general factor into the most loaded explains. Right. Then here they are using very much notation. Right. Number of iterations converges 100. Right. Fact Yeah. Factor transmission matrix is here. So because that you can see here that both sides are balanced in here. Right. The rotated factor matrix. So the rotate factors may rotate කරලා අපිට ගන්න පුළුවන්. Right. Since these are the communities, those things. Right. So then now what we can do is if we use these rotation methods, right? So you can see here there are two latent variables in here. Then that is SPSS anxiety and technical anxiety. Right, the total variance explained. True, false. Rotating change how variances are distributed, but not the total community. Yeah, what is the answer? Yeah, yes. Right. Likewise, we can go for these rotations. Right, අනිත්‍යවත් ඔය විදිහටම යන්න පුළුවන්. Right? So we'll go for a simple analysis. I put analysis එකට ගිහිල්ලාම බලමු. Right. So then we can go analyze dimension reduction factor. we can go for this factor rotation. Yeah. So we'll see. ඒතර මම මේ ෆැක්ටර් ඇනලිසිස් එකේ පොඩි සරල අදහස කියන්නම් ඉස්සෙල්ලම right ඔයාලට මේ ඇනලිසිස් එක පුළුවන් මේක බලලා හරි කරන්න right so ඒ කියන්නේ මේ මම දැන් කරපු ස්ටෙප්ස් එක ආපහු බලාගත්තා නම් ආයෙ යන්න පුළුවන් right so then මේ ෆැක්ටර් ඇනලිසිස් එක වෙන්නේ right දැන් අපි මේ simple question එක ගමුකෝ right එතකොට the statistics make right so then these questions are based on to check that attitudes towards statistics and technology, right? So then this unobserved variable, so we have to convert this into observed variables, right? For that, so we have to send that sum of the collected data, right? So therefore, hey, හින්දා ඇත්තටම මේ method එක අපි හරියට බලා ගන්න වෙනවා, right? Okay. So actually that's what I want to explain. එතකොට මේ principal component analysis නැත්නම් මේ factor analysis එකෙන් වෙන්නේ අපිට පුළුවන් මේ අපේ දැන් question එකක් අපි ගත්තාම ඉස්සෙල්ලා මේක තියෙන්නේ අපි හිතාගෙන තමයි හදන්නේ මේ fact එක යටතේ මෙන්න මේව තමයි තියෙන්නේ කියලා but statistically so how we can separate these outputs to as we needed through this SPSS software. Actually, therefore, it's very much important to learn about SPSS because without that, then actually, so we can't do the analysis and the other things in these days, right? Yeah. Then we'll. So there are some questions from last week. Sorry, last day actually. Few questions tika chutta බලලෙමු. The first one is about පළවෙනි ටික regression, correlation, and chi-square. ඒ ටිකෙන් තියෙනවා. Right? Regression, correlation, and chi-square. Below the simple data set heights and weights of 10 men, right? So draw a scatter plot for the above data. Scatter plot right? We can draw a scatter plot. Yeah, so these are the height weight measures. Right, then we have to draw a scatter plot. Then graphs, legacy dialogues, scatter. Right, so then here for x, y-axis, weight, x-axis, height. Yeah, then this is the scatter plot. The scatter plot we can see a positive relationship here. So then somewhat we can see the positive relationship is there. Right? They use the SPSS to generate model summary, ANOVA and coefficient. SPSS right? Right, so we can go analysis. We can go right rows, catapult the above data, interpret the regression output. Then අපි යමු. Analyze. Then we can take this. These are the outputs, right? Interpret the regression output, determine. Yeah, so then regression, second one, like අපි බලමු. Second one, the chicken farm owner sets the testers new feed supplement to increase the egg production. The dataset consists of 12 groups of 10 mission groups of 100 chicken each, receiving different supplement levels. Right, draw a scatter plot again. So you have to draw the scatter plot for this. Right, we can enter the data. Right, so here we want to enter this data also in a file, new data. Right, variable view. Right, we have to enter the data here. Then group number, we need 3. Group number, feed supplement, group number, feed supplement, feed supplement, number of eggs. Right, so then we can enter the data 1 to 12. Row scatter plot. Before that, we need to enter the data. We'll take the outputs. Now we make the integram data figure. Like we can enter the data here. Group number. Then fleet supplement. Yeah. Find number of eggs given here. Right. So then this is how we can enter the data. Then the questions are given. Draw a scatter plot here. Definitely we can draw graphs, legacy dialogues, scatter plot. So definitely we can draw the scatter plot. Y values is number of eggs. X is number of foods. Yeah. So it is not easy to observe a relationship, but we can see there is some relationship is there. Right? We can't say exactly what is it, but so we can see according to that patterns, right? Then formulate the null hypothesis and the alternative hypothesis. Use uh, model summary, those things. So then we can go correlations. Analyze covariate, bivariate. These are the two variables. Okay. Then we can go options. Yeah. interpret the relationship with speed of the egg productions. Then we can go analysis, correlate by variate, SPM relationship. SPM correlations, yeah, it's become non-parametric correlation. So here it's given, uh, no, which type of correlation is not there. So we can take for this as අපි අපිට කැමති විදිහට ගන්න පුළුවන්, right? The next one, ඊළඟ එක, next question is this one. A psychology student examines long-term effects of alcohol on reaction time and measuring the uh, times and spells alcohol consumption per week. Right, again, we can go okay. Alcohol consumption units and reaction time, milliseconds. Time, the other one is alcohol units. Units, time, units and time. So we can have a label here. Alcohol consumption units. Alcohol alcohol consumption units. Alcohol consumption units. And next one is reaction time. There are some more. Ten, 7, 20, 6, 80. Reaction time in milliseconds. It's given here. This had Shampahar. Right, 22. 261. Yeah, 261 here. All right, it's okay. Then 247.6. Right. Then here also it's given row scatter plot. Then we can draw a scatter plot, graphs, legacy dialogues, scatter plot here. Then units for x-axis, reaction time for y-axis. Okay, then we have, then this is how we can draw a scatter plot. So we can see that some deviations are there, but that is in positive relationship. As we'll see then. Compute Pearson and SPM and correlation coefficients. Then analysis. Analysis correlate bivariate. So we have to take this two. Then Pearson and SPM and correlations both. Then correlations here, SPM and correlations. Pearson correlation is there. Then SPM and correlation is that is taken as non-parametric correlations. Right, both are interpreting there. Right, next question. Right, the data set examines how the study habits, sleep duration, and exercise routines influence the students' academic performance. It is designed for the multiple linear regression analysis. It is to explore predictive relationship among these variables. This data set examines the relationship between students' study habits and sleep patterns. Right. Right. Yeah. So this is the data set then. You can enter the data set. So then we can go for the questions. Calculate the mean, median, and standard deviation for the study hours, sleep hours, exercise hours, and exam score. Mean, median, and standard score. Yeah. Then we can go analysis. Descriptive statistics. Descriptive result options. Yeah. Mean, median, standard deviation. No. We'll go for analysis, descriptive statistics. Compare means, so frequencies, or steps expressed. So we go to frequencies then. Mean, median, we have to calculate. Mean, median, standard deviation. Right, this so. For study hours, okay, sleep hours, exercise score, and exam score for all. Right, we'll take the output. Compute the correlation coefficients between. Okay, we'll see the output. We'll analysis, compute correlation coefficients, analysis, right? It's okay. Yeah, we'll take this one. Next question is compute the correlation coefficients between, yeah, so we found it. Correlation coefficient between, no, we'll go to that. Calculate the mean, median, X, okay? Compute the correlation between students' hours, sleep hours, exercise hours, and exam score. Then analysis, correlate, yeah, by variables. Yeah, right. So these are the correlations. This is the output, right? Then we can find the correlation. So flags are indicating that it is in a confidence interval 0.05 or 0.01. Okay. Compute the correlation between, that's okay. Perform the multiple linear regression with exam score as the dependent variable. So then this is different. අපි ගිය සතියේ sorry එදා කලින් දවසේ කතා කරේ only simple linear regression, but this is multiple linear regression. So only many independent variables and only one dependent variable, right? So then a dependent variable is study out. So we'll try to take that, right? Analysis, regression analysis, general linear model, univariate. Dependent variable is exam score. These all are independent variables. Yeah, this is multiple linear regression, right? Write the regression equations based on the coefficient obtained in this model. Yeah, so we can take here which predictor variables has more significant impact on exam score. We don't know. Next one is any are any predicted variables inside in the model justify your answer, right? What is the R square value of the model? Likewise, you can answer, right? Then any questions so far? මොකද ප්‍රශ්න තියෙනවද last day session එකෙන් තව කාට හරි? ඔව් අද එකෙන් හරි ඕන එකකින්. Questions from any sessions. මොන හරි ගැටලු තියෙනවද? Yes. Anything to say then? මේ sessions වලින් මොන හරි ගැටලු තියෙනවද? හසිනි? Let's talk then. This is actually last discussion then, because all the things I covered with you then, as I showed in the syllabus, right? So we'll take that again. අපි ආපහු ගමුකෝ කලින් දවසේ document එක. This one. I think you can see this. Yeah. So then we discuss about these things. overview, defining types, importing those things, and measures of center, mean, median, mode, range, that things, then creating histograms, box plots, bar charts, then how to write the null hypothesis and the alternative hypothesis, then independent sample t-test, paired sample t-test, one sample t-test, one-way ANOVA, and post-hoc test. Then we discuss PS and Spearman's correlation, simple linear regression. Then today, we did that multiple linear regression as well, then chi-square test, and also factor analysis and reliability testing. And these things we discussed. Right, so therefore, then just I'm asking now, before stop today's session, right? Today's means that this whole course, no? ඊට කලින් any questions to ask? Not a hundred, right? So from these sessions, any questions to ask? Right, and if not, so tell me something that I don't know, because this thing is for improvement of this course actually, because there are then you after you and other batches are joined for the with this course. So if you so please tell me in few words, so how you feel about this course actually, because if you have anything to improve, then we can take from that. And also if you need some more clarifications also, I can help with you, right? මොන හරි ඕන නම් සහ ඔයාලගේ analysis වලට ඕන තව part එකක් එහෙම නැත්නම් ඔයාලගේ දැන් මගේ variables තියෙන මෙහෙවා මම මොන test එක දෙකට දාන්න ඕනේ, right? Likewise that questions you can ask now. Yeah, so anything to say? මොන හරි දෙයක් තියෙනවද කාංචනා? භාග්‍ය, හසිනි, හසිඳු, සත්සරණ, anything? එක්කෝ ඔක්කොම තේරලා තියෙනවා නැත්නම් මොකුත් තේරලා නැහැ. ඒ කියන්නේ අහන්න දෙන්න ඕන. Right? Yeah. So මොකද කියන්නේ? ඔයාලට එහෙම ප්‍රශ්න නැත්නම් we can stop this session from here. So again, I'm asking because it's well, this is actually your time, because we have some few minutes also, right? So therefore, so if you have any questions, so I can answer actually, because in the last sessions they asked some questions about their researchers, right? So then then I discuss with them how they can analyze those things. That's why I'm asking again from you, right? I think there are no questions. Therefore, then we can finish this course from here. අපිට මේක මෙතනින් නතර කරන්න පුළුවන්, but so if you have further questions, so you can post that questions through this through your WhatsApp group. Then I think definitely they will uh, direct that questions for me. Then I will help you for your analysis always. Right. So එහෙම ප්‍රශ්න නැත්නම් අපි මෙතනින් නතර කරමු. එහෙනම් good luck. Right, bye.